Hi everybody, I am Nikita Yeremin, an assistant professor in Donbass State Engineering Academy, and today we'll have a talk on the Python programming language essentials. Here's a brief disclaimer. Our lectures are based on the MIT OpenCourseware materials, the course named Introduction to Computer Science and Programming in Python. You can get to the URL provided and find all the course materials there, which is really recommended to do. Let's start with considering what a program in general is and how it can be written in Python language. A program is a sequence of some definitions and some commands. Definitions are evaluated and commands are executed by Python interpreter in a shell. Commands or statements instruct interpreter to do something. This can be, for example, a printing command, some calculations, reading from file, network interactions, etc. Commands can be typed directly to Python shell or stored in a file that is read into the shell and evaluated. Programs consist of objects and manipulate objects. Objects in Python have a type that defines what kind of operations programs can execute on them. Some real-world object examples. For instance, Anna is a human. She can walk, speak English, maybe other languages. And Chewbacca is a Wookiee, so he can walk, produce different sounds, and do some interesting things. Okay, so objects can be scalar or atomic, meaning they cannot be subdivided into smaller parts, or non-scalar. Objects have an internal structure you can access in your code. Here are some examples of scalar object types and values for them. Int type represents integers, for example 5. Float stands for real numbers like 3.27. Bool type represents Boolean values which are true and false. Non-type is a special type for identifying that there is no value at all. There is a type function allowing you to see the type of an object. For instance, executing a type 5 statement will return int, and 3.0 passed to type function as argument will return float. Sometimes you need to convert values from one type to another. You can use type conversion for that, specifying a type name and passing a value as argument to it. For example, float of 3 will convert integer number 3 to float number 3.0. On the other hand, converting a float number 3.9 to int will produce integer number 3, truncating the original float. One of the most useful statements in console scripts is a print statement. It allows you to show some output to a user. Now we got to expressions. Expressions allow you to combine program objects and operations. When evaluated, expression has a value which has a type in turn, just like any other value in your program. Let's see which operations are available in Python for integer and float numbers. First, there are basic arithmetic operations, sum, difference, product, and division. It's worth mentioning, for sum, difference, and product, the result is int in case both operands are int, and the result is float in case both or one of them is float. For division, result is always float. You can also get a remainder of division, one number by another, specifying a percent operator. Two asterisks operator allows you to raise a number to a power specified by another operand. You can use parentheses to tell Python which operations should be executed first. Operator precedence without parentheses is the following. First goes raising to a power, then multiplication, then division, and finally plus and minus operations are executed from left to right as appear in the expression. One of the fundamental operations in programming is assignment of a value to a variable. In Python, as well in the bunch of other programming languages, you can use equal sign for it. When the assignment is executed, Python interpreter does the following. It allocates the needed amount of memory, if this is first assignment to the variable. Then the value is stored in memory and variable name is bound to it. You can retrieve value associated with name or variable by invoking the name. In our example, let's type in pi in your program or Python shell. Question is, why do we need to give names to values of expressions? The answer is, of course, we need to reuse it in our code. It's also much easier to change the code later when you only need to change the value in one place instead of changing each part of the code using it. Let's see what's going on behind the scenes when we rebind variable names using new assignment statements. First, we assign a value of 2.2 to the radius variable. Later in our code, we increase its value by 1. Now you can see the radius variable stores 3.2 number, and previous value is still stored in memory, but we lost a handle for it. Python interpreter will clear this value from memory afterwards. So now we understand how Python programs work in BASIC. We know how to use operations and build expressions with them. We also know how to use assignment operation and how it works. More to discuss in the next video.